Good to go?
Yep.
All right, so I'm Brian. This is Code as Data, Metaprogramming in Elixir. Wrong slide, there you go. How many people here have written a macro in Elixir already? All right, good. So if you have any questions, you should find one of those people and ask them. Anybody who knows RJ Osborne, who I believe works here now, he once told me that you'll understand macros in Elixir when you realize you should never write a macro in Elixir. And since I'm still writing them, obviously I'm failing to understand them still. I've been playing with Elixir for a while. Fun story about me. Seth MacFarlane actually had to contact me about using my likeness rights for the original Peter Griffin. And if you believe that, you should talk to Johnson. He's got something he would like to sell you. I do work at Pillar or Accenture or whatever we're called now. Believe me, being one of 480,000 employees makes you feel really special. So we're going to talk about metaprogramming. To do metaprogramming, we're going to use all of these things on the screen here. We'll go through them really quickly. We'll talk about them, and then I want to actually show code using them because I feel like it's a better way to try to learn. Quote is the kind of foundation of everything. It's how we turn Elixir code into abstract syntax tree or quoted expression. When Elixir compiles, it actually runs through and expands all the macros, turning them into AST, and then it actually then compiles the AST into the code that is actually ran. And that's what gives us all the power for metaprogramming. Quote, you can just use it like any other function, sorry. And if we do, so we can see that we get, is this not big enough? Probably make it bigger. Is that good? Bottom of the screen there. Well, almost got it. So basically that turned into, I'll rerun it. That turned into a 3-element tuple. The 3-element tuple is the fundamental building block in Elixir AST, right? The first value is the function to call. The second one is the context, where you see things like imports and stuff like that. And the last is a list of arguments to said function. It gets very hierarchical. So let's just write a quick if statement here. And so we can see you start getting nested 3-element tuples to represent your code. All right, so like right here, for example, is the quality function being called right there. If I could get that stupid Mac thing out of the way. And that in turn becomes an argument to the main if function, right? So on and so forth. Do and else are actually just magic keywords that become a keyword list as the last argument to a function. Does everybody know what a keyword list is? No? Okay. So a keyword list is looks like this, right? And technically it's just a 2-element tuple in a list where the first element is an atom. So it's really important to understand those in Elixir. It's one of the fundamental building blocks of using Elixir. All right. Unquote is the opposite of quote. It turns our AST code back into Elixir code, which we have to use sometimes when we're writing macros. We're going to use pattern matching, which hopefully everybody's familiar with. We're going to use module attributes. You've seen those before. They're the @ symbol in a piece of code. So like right here, you might see stuff like @name is Brian, right? That is a module attribute. A lot of times you'll see them used as just kind of a constant, but in reality, oh, sorry, bigger. Nope. You'll see them as a constant, but in reality, it is essentially a variable that we can use during compilation to track things as our macros run. And using them is an important part of being able to write macros well. Before compile is a hook to, guess what, run things right before compilation. And then macro pre-walk and macro post-walk are the most powerful functions we have to walk the AST tree, right? So pre-walk essentially lets us evaluate a node before it goes into the nested nodes underneath it. Post-walk would be the absolute opposite, right? We're going to go deep first and then actually evaluate nodes on the way back out. Which one to use depends on your situation. I know I went through that quickly because it's just staring at a screen and somebody talking, right? So let's look at some code. So we're going to talk about macros with 2 libraries that I wrote and one other kind of contrived example. So I wrote a library called Placebo because we wanted to have more expressive mocking. I don't like mocking, but when I needed it, I wanted to be more expressive. So when we sat down and talked about it, my goal was to essentially copy our spec, right? So in Elixir, I wanted to be able to say allow some module, blah, 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 return that. And it turns out that if you just make this call, it turns into that AST, right? So let me actually go to the next slide because I think I have a better example there. So it turns into that AST, right? You saw me run it, so you know it's true. The module is defined in that part of the AST, right? It's actually an aliases function that's going to resolve some module to see if you have it aliased or not. The function is right there, right? And the arguments are there. And so once we know that structure of the AST code, then we can actually, get rid of that, just pattern match into our macro that structure, right? So we're just pattern matching right out from the AST, the module, the function, and the args. And so now once I have those, I can figure out what to mock and what stubs to set up and all that other stuff. So if we actually run that, or maybe not. Oh, I'm on the wrong branch. All right. We don't need to run that because I have to switch branches to run this real quick. So it works. But that's just a real quick example of treating code as data, right? So somebody else is writing that allow statement. Go back. Here. Somebody else is writing this allow statement, and we're treating the code that they pass to us as data, ripping it apart, and learning things from it that we can then use to set up mocks, set up stubs, whatever we need to do. All right, does anybody have any questions? I like questions, so this is informal. Ask questions if you got them as we're going. If we wait to the end, we'll forget everything. There's a snide comment there.
Is there an example of a context up there that you might actually pay attention to?
Oh, God. They're teasing me. I did this talk at a conference that they were at, and they teased me about this the whole time. Yes, this is a context right here, this alias false. That's meta information given to the compiler when calling the function. All right. Bunch of jerks down here. All right. So that was a real quick example that I wanted to kind of get through quickly just to show we can take code in as arguments to macros, pattern match against it, and start ripping it apart. Now I want to do another kind of style here. This is a kind of a contrived one. It's similar to kind of like an ecto schema, if everybody's seen that, although those are obviously much more complicated than what I'm about to show you. And we're actually going to do this in code here. All right, so our goal here is we're going to make the thing on the left create a struct. All right, everybody familiar with structs? It's an Elixir map with a name, essentially. We're going to make it create a struct, and we want that struct to have default values and actually make sure that there are certain fields that are required. All right. Over on the right, we have the code that we're going to be talking through to make that work. And if anybody doesn't know, I'm going to be using an awesome command called git crawl. Okay. Come on, Spacemax. There we go. So, so first things first, right? We're going to implement a special macro called using. And you saw right here, I'm saying use this PillarCon schema module. And that is going to call the using __using __ macro. And whatever quoted expression, AST, that we return out of the macro is just going to be put in place inside that other module. And so what we're going to do is we're going to import a schema and register a module attribute. So this is the first example where we're actually going to be setting up a module attribute. Remember, that's a variable used during compilation, right? And we're going to be registering with the name schema fields and setting it to accumulate true, which pretty much means as I shove things into it, it actually gets appended to a list, right? That's all accumulate means. And then we're going to define a field macro to accept the name and options. And all we're going to do is take that information and shove that into that module attribute, right? So you can see that over there. If I then try to create one. It's going to blow up, right? We haven't actually defined any struct yet. All we've done is kind of capture some information about it. So the next thing we're going to do, there we go, is we're going to add in some more stuff here, right? So we're going to register a before compile hook. So the compiler is going to give us control after it's evaluated the entire body of the module, but before it actually compiles it, right? So the module is going to be AST at that point. And we're going to, still registering the same attribute. So now in before compile, we're going to grab the information we shoved in that module attribute, right? Which are just names of fields and the options associated to them. We're going to map over them and basically just turn them into a keyword list, right, of name and options. I'm sorry, not a keyword list, just a list right now of a name. And then we're just going to do a quote call here, right, of our defstruct command. And so that's going to take the defstruct command, run it through quote, which will turn it into AST, and replace that into the other module right before compilation. Everybody with me? All right. So, Jeff.
Is at before compile a predefined module attribute?
Yes, it is a compiler hook defined by Elixir. That you. So yes, all right, good point. I jumped over that. Saying before compile in a module just calls __ before compile __ by default. You can specify a different macro name if you so choose. I've never seen anybody ever do that. But you can.
I'm just curious why they have a totally different convention between how they use the __ using macro and the __ before compile macro.
Meaning one is a use keyword and one is a module attribute? Your buddies with Jose, call them. I don't know. That's the best I got. Huh? Yeah. What do you say? All right, so where were we before I was interrupted? So now we can actually create a struct, right? Because we've told it to output the AST for defstruct into our other module. So we can now create a struct, and we have all of our fields named properly. There's no options to them, but we have names. So we've made a step. All right, so now we just want to do the default values. So we're going to take those, as we're mapping over those schema fields, now we're going to create a keyword list, right? That is the name and a set of options. In this case, we're going to go ahead and grab the keyword default or nil, if it doesn't exist, and make that the value of the keyword list. And it turns out the defstruct can take a keyword list, right? So we just are passing that straight into defstruct, all right? And that is going to now create us a struct with default values, right? Because instead of just passing a list of names, we're now passing a keyword list, which is names and values. Everybody on board? And see, now we get our default value of 21. Can everybody see this down at the bottom? Is that working? We're getting nods, okay. All right. So now we have to deal with required fields, right? So in Elixir, there's a special module attribute, again, a very special one called enforce keys, where you can have in the module of a struct to say these keys have to be in the struct when it's defined. So we're just going to loop through those same fields that came out of that module attribute, look for any of them with required true to make a new list of all the fields that have required true, and just pass that to enforce keys, right? Again, in the same quote block, because that AST is just going to be put over into that other module. And now it is going to blow up because I don't have the name field defined. And once I define a name field, I get my struct with a default value and required fields, right? So this is a kind of contrived example, because I'm not sure why you would do this outside of what Ecto is doing. But it shows how to use before compile, where you can gather information as the compiler is going through the module, right, into module attributes. And then right before compilation, you could take that information and add things to the module, in this case, a struct. But that could be other functions, right? In fact, EXUnit, right, how EXUnit works is the test macro is adding all that stuff to module attributes, and then in a before compile hook, it's writing out all those functions that are all those tests, and a special function which says run all these functions in this module, the tests, right? So EXUnit is doing this exact same technique to run all your tests. Any questions at this point? All right, everybody's quiet today. All right, so we did that one. So the last one and the most complicated one, I think that I've done at least, is I wrote a library called Chekhov. Has anybody here done Groovy development and used the Spock testing framework? Okay, no. All right. Well, Spock had a fabulous feature that did like data-driven tests, where you could essentially write an assert like the one on the screen here, A equals B, and then set up a where clause to say, I want to run that for when A equals 1 and B equals 2, or A equals 3 and B equals 3. So you could quickly add test case scenarios and not have to duplicate the actual body of the test, right? So it made it wonderful to testing edge case and stuff like that. So I really wanted that in Elixir, and so I thought I'm gonna give it a shot. So I made a library called Chekhov that does this, and we're not gonna go through all the details of Chekhov. We're gonna go through the guts of what it's doing here, right? So that block of code turns into that AST, right? The __ block _ function is a special function in the kernel special forms area of Elixir that is essentially saying, this is how you make a block of code, right? The arguments are just other statements separated in a list, right? That's all it is, so I know it seems weird, but that's all it really is, just a block of code. The body is in the arguments. You can see there's no context, but in the arguments here, we can see our body. What we're trying to do essentially, right, is we want to take the information in the where part, right? We want to rip that out, and we want to make new variables with those names, and then just repeat the test. So we're trying to take that where out, right, and then write in new statements to set variables equal to those values, and then just repeat the test, right? var ! Is a special function in macros to basically say these variables are dirty, right? Macros by default are what's considered hygienic. Any variables in your macro are not seen inside any body of the code that is passed to you, but var ! Can change that. So you can mark these dirty, and that's a way to introduce scope to bodies that are passed to macros, right? Right. Oh, that's the last slide. All right, lots of code to come forth. Here we go. So we're gonna do this in a test, so we can actually run it and play with it. And if you guys want me to try the things, it's all runnable, so we can just play with it like we want. Currently, it's gonna do nothing, right? We're just gonna run that same block. Well, I guess it's a block with slightly different in the where clause, but it's the same idea block. We're gonna get that block in AST. It's not gonna really do anything at this point. So the first thing we wanna do is we wanna get rid of that where clause. Right? So what we're going to do here is we're going to use macro pre-walk for the first time, right? So we now have this AST tree, right? This hierarchical tree of nodes that tell us different functions that want to be called in what order. And we're going to pre-walk through them, right? And for each node, as we get it, we're going to say, is it the where function, right? If it's not the where function, then we're just going to return the node unmodified and include that in the outputting AST. If it is the where clause, we're going to return nil, which basically says do not include it in the output anymore, right? So this test body now is going to be the AST code without the where clause, right? So we're just ripping that out of there, which we should be able to see in a terrible... There you go. So we can see it there. We have our same block there, but we've ripped out that where clause, right? So now if we let this go to compilation, it's not going to compile the where in, and therefore not throwing an error, right? Because where It's not actually a function defined anywhere. It's just a keyword that I'm using. So the next step is we need to capture what where is trying to tell us. So in this case, right, we're going to use a variant of prewalk, the Arity 3 version of prewalk, which almost acts like a reduce, right? We can send in an accumulator and accumulate information as we're determining should these nodes be in the resulting AST output. My accumulator is nil here. I'll just use a mouse, I guess. I know using a mouse in Space Max, right? My accumulator is nil to start with, but you can see I'm now pulling it in on the function as well. Same idea here. We match against the where node. If it is the where node, then I'm saying I want nil in the output AST expression, but I want the expression to now be in my accumulator. If it's false, then we're just going to leave the expression alone and leave the accumulator alone. Right? So now the resulting tuple that comes out of that is my test body without the where in it and the where clause in another variable. What did I do? There we go. So we can see that we now have the body still without the where in it, and we have the where clause with information we need to do what the end user is trying to tell us to do, right? Which is, I want to run that thing with these different scenarios. Anybody lost? All right. Are you lost? No. Are you behind? You nodded your head, didn't you? We can slow down or go back. Okay. All right, so now we are going to take that where variable we have, and we're just going to pattern match against it again, right? And we're going to pattern match it out the variable section, which is that first sublist, and then the tail of that is all the data, right? And the order matches, so we know which one is which. We're going to then map over the data and just zip each data list with the variables list, right? And that's what I'm going to start calling a binding at this point, right? And we can see it here. I should have changed my font. I didn't think about it. I apologize. So now we have this list of lists, and each sublist is one of the scenarios that we want to run, right? A is 2, B is 2, A is 3, B is 3, A is 5, B is 10, right? So that's now, we've got this information now that tells us what do we want to do. All right, so now we're going to go through that binding, and for each binding, all right, so we're talking about this section right here, we're going to turn it into an assignment statement, right? Equals the name, so this is how a variable looks in AST. The function is actually the name of the variable, and the argument is just the module. It's kind of a special form. So we're just going to say we want to assign that variable equal to the value. At this point, I'm just printing out and showing you, if I can make it bigger, the actual assignment statement. So we can see them all sublisted out, so we still have all of our data, and we're turning it into AST over time here. And finally, right, what we're going to do is we're going to take those variables that we now have, right, for each one. We're going to pattern match the test body out, right? So right there, we're taking the test body and we're pattern matching it so we have its context and its args. And we are just going to return a very similar one, but has our variables now prepended to the args list, right? So in the AST now, we're defining those variables before we're executing any of those other statements that were defined in the test body itself. And so now, zoom in on one of them. So now you can see that we have this block, and we have our assignments first, and then the assert to determine are they equal. Sorry, couldn't talk there. Are they equal? So now we are just about done, right? All we need to do now is evaluate our blocks. So to do that, Elixir contains a fabulous function called code.evalQuoted, So that takes a quoted expression and runs it against some bindings and an environment. In this case, we're having no bindings and the default environment, which is the special underscore underscore env macro. If we do that, then we actually see that it ran, and we see that 5 does not equal 10. All right, so let's sum that back up again, right? So we took this test body, right? Let me go up here. We took this test body here, right, that was converted to AST for us. We ripped out the where clause to figure out what are the variables they want to define for each run of the test body. We then mashed up the variables in memory to try to create these bindings, that is, the name of the variable and the value in sublist. And then we turn that into actually assignment expressions, in AST. And then we just prepended those assignment expressions to the rest of the test body minus the where, and then repeated that for each of the assignments, right? And the result is this test now checks that 2 is 2, 3 is 3, and 5 is 10, and it fails when 5 is 10. And we can prove all this, right? Because we change 2 to 1. We now see that it's going to fail on 2 equals 1. So every time we run this, the compiler is going to do all that work, right? Ripping apart the AST, recreating it, and letting us loop over things. How are we doing? I got a thumbs up over here. Are you actually following? All right. So this is what I would think is a beginning start to understanding macros in Elixir, right? Metaprogramming in Elixir is all about doing things at compilation, unlike Groovy and Ruby, right? They're much more, I'm just going to muck with things at runtime, right? This is all about doing things at compilation. However, it's once you get into it, I know I made that quote about RJ earlier, but once you really get into it, it's not scary. It actually starts making some sense if you just dive in and start messing with it. That's what I did. I just started making macros for very little actual value, right? They were just stupid that I just wanted to figure out how to do stuff. To the point where I was working on a project with Johnson and we wrote macros that write out macros. Crucible.
Oh yeah, that's good.
Yeah. Very little value, we just wanted to prove we could do it. So macros are actually used all over the place in the Elixir frameworks. Like I talked about EXUnit using test already. Ecto is using it whenever you define a schema in fields. Phoenix is using it in the router. Actually, that's probably plug and Phoenix in a mix. So they're all over the place, and they're very, very valuable when you want to create frameworks or give more power to your users quickly, right? Because you're abstracting away complexity and putting more power in their hands quickly. Now, like runtime stuff in Groovy and Ruby, you can create a real mess for yourself. So there's something to play with and experiment with and not use everywhere, but extremely powerful to have in the toolkit, right? And that is it for me, unless there are any questions. Kenny, you look asleep. Yes, Johnson.
So placebo, that's a really good name for a library.
No, Johnson named placebo. RJ named Chekhov, to be clear. Both those are out in Hex if you want to use them. We use them on our team regularly, but yeah. Anything else? I disconnected? Thank you very much.